Okay, so this video we're going to go through another transformation question. So list a sequence of transformations which maps y equals root x to the image a quarter times root 5x plus 2. Okay, and again our first step is just to make things look the same or similar. So I'm going to rearrange this guy. So if I multiply for both sides, I'd get 4y dash equals square root of 5x plus 2. Okay, and now it kind of looks like my original pre-image. So that looks like that, and if I make a substitution here, that looks like that thing inside the square root. Okay, and what are we trying to do? We're trying to find again a set of x, y coordinates mapping to the image coordinates. So my objective is to find x dash and y dash. So now I equate things. I say y is equal to 4y dash and x equals 5x dash plus 2. Okay. Rearranging to solve for y dash, we get y on 4, and rearranging for x dash, we get x minus 2 over 5 is x dash. And so what does that mean? It means that every single xy coordinate goes to this, and we can write this one in a couple of different ways. We can write it like this, or we can write it as x on 5 minus 2/5, and y dash goes to y on 4. And from this sequence or rule, we can read off the transformations. So because of order of operations, if I wrote it like this, then it would be division first and then the subtraction. So I'm going to write down the transformations. I'm going to do the dilation first. So x on 5, again, what's happened is it going towards the x-axis or the y-axis. Well, if you have an x and y point and it goes to x on 5, it goes there. So it's going towards the y-axis, so it's a dilation by a factor of 1/5 from the y-axis. And then what's happened, it's translated 2/5 to the right, left, translated 2/5 to the left, or 2/5 in the negative direction of the x-axis. And then this one here, the y on 4, it's another dilation factor. So it's every single xy coordinate is going like this. You're taking a quarter of y, so it's going towards the x-axis, so it's a dilation by a factor of a quarter from the x-axis. Okay, or equivalently, that one could be written as dilation by factor a quarter parallel to the y-axis, because it's going in the same direction as the y-axis. So that's if we wrote it like this. If we didn't write it like that, then there would be a different answer. If I wrote it like xy goes to x minus 2 all divided by 5 and y on 4, that's x dash and that's y dash, then I would have to do the translation first and then divide by 5. So translate 2 to the left, and then dilate by a factor fifth from the y-axis, and then the other one is dilation by a factor a quarter from x-axis. So that's an alternative way of writing it. And again, you can always do a quick little check if you're unsure. So let's just check with the first one we did. So here, y equals root x, we know that that has the point 1, 1 on it, and it gets transformed to x and 5 minus 2/5 and y and 4. So if I did that transformation, 1, 1 should go to 1/5 minus 2/5 is minus 1/5, and y on 4 should be 1 on 4. So it should go to that, right? So if I sub in the x and y coordinates into my image equation, I should get back something that makes sense. So y dash is a quarter root 5x plus 2. So if I sub this in, negative 1/5, I should get back a quarter. Five times negative 1/5 plus 2, that is a quarter times negative 1 plus 2 is 1, so you get back a quarter equals a quarter, which is just one way of checking. So you've got that one right. Alright, and that's it for that video.